I forgot to say this. Do have something new. Evidently, they have these in Financial Services Office every month that they have deadlines. These are all the scholarships whose deadlines are in December. And they do this every month. I didn't know that. Or all the months they do have deadlines. And look at that. Front and back. Tons of them. If you want to take a look at those. And if when you finish with that, a lot of them are specific for like cosmetology or something else. But, you know, if there's anything that's appropriate for you, take note. And they only gave me a few copies, but you can get more at Financial Services Office. Okay. Now, I did not get your test graded. I started on it, but didn't get it finished. I was trying to get everything graded from the last class because their final depends on this comprehensive. Yours isn't, so I'll get you yours whenever I can. I'll pass you out the last test today. Yeah. But the first test, you know, the one you gave me yesterday, I didn't have a chance to finish grading it. So, what's that?
I said, well,
yeah.
I guess, what's the Thursday?
Right.
I guess I might get a chance to look at it before I turn the other one in, just for
right.
funsies.
Yeah, I hope to spend some time this afternoon grading it. I only got 3 hours. It depends. Yeah, but then Friday, I hope to get most of the grading caught up tomorrow.
And I want to say there's no box for next week on the work study.
Probably not. I don't. Yeah. Right. So if you're on campus, you can come by and pick it up. But
yeah. Probably whenever I do my tutoring.
Right. Are you tutoring still next week?
I guess.
Yeah. Good. I'm glad you are. I didn't know.
Well, I mean, I can come up here and also work on some things. So
right.
It's kind of 2 for 1.
Okay. The other thing is, and saying this mostly for those at home, student course evaluations are now open. Please don't forget to do the student course evaluations. Do those.
Why don't they have these online?
I don't know. You can ask them.
Do they have more packets up there?
Yeah, they have plenty of them down in the Financial Services Office. Yeah, but I mean, I've got several too. I don't know where they are right now, but
It's okay.
right there. Yeah. See, they gave me several.
I'm going to take one.
Okay, you certainly can. Okay, so please do the student course evaluations, and I will be passing out the last test at the end of class today, and it's due by next Thursday. Technically, it would be due, this class starts at 9:30, so technically it's due Thursday by 9:50, but anytime. If you get it to me sooner, great, you know, later will be, but I need it by the end of the day on Thursday. I'm here till 8 o'clock on Thursday evening, so got plenty of time to get it to me, but I will not be in town on Friday. We're going to be driving to New Orleans on Friday, and I won't be back until Monday morning, and grades are due Monday at noon. So please get it to me before Thursday, before I leave campus on Thursday. All right. That's mostly.
Will this one possibly have bonus questions on it? Or?
No, this is, I think, this is going to be what, yeah. Because I made it up last night, and I didn't go any beyond what we'll be covering today. All right. Any other questions before we get started? Okay. We're on page 160, chapter 4, section 4.6, variation of parameters. Example 3. Okay. Here's how it reads. I think they're doing some yard work. Yeah. I think that's a y double prime, if I can read it right. Minus y is equal to 1 over x. Okay? Now, how would you start? Yes, auxiliary equation.
So that would be m squared
M squared
minus m.
minus 1,
Oh, minus 1.
right, is equal to 0. Because you do it for the homogeneous part, the left-hand side, with the right-hand side equals 0. Then we'll come back and do the particular. Okay? What does that tell you?
Okay, so there's a double root of 1.
Nope. That would be if that was m squared minus,
Square root 1.
which is, and negative 1. Okay. So m is equal to 1 or minus 1. Okay? So what does that leave your solution to be? Your characteristic solution. Y sub c would be
C1.
C1
Would just be
e to the x
And then we gotta have another one, so plus C2 e to the x again.
negative x. Right. Okay. Yeah, minus 1 is your m, right. Okay. And they wrote it the same way. Surprise, surprise. Now, what they do next is do that thing with the Wronskian, okay? Which is do the W, and remember that is the determinant of the, forget the C's here, the function on top, e to the x, e to the minus x, and then in the second line is the first derivative, which is e to the x minus e to the minus x, right? Okay? Now, when you do that determinant, what do you get?
That would be 1, negative 1.
Negative 1 equal negative 2. Perfect. That's your Wronskian. Negative 2. Now, that's your denominator under your of your U1 prime. Okay? Now they're skipping lots of steps here. Well, what is the numerator for that? All right. What you had to do then is well, you almost have to go back and set up what your situation is here. Okay, I don't see how they can do it without doing some more than just saying, here's what it is. The Wronskian, you can remember, that's the denominator. The numerator you get from this, okay? Remember you, sorry. Sorry. Okay, if you go back to your two equations, if you see on page 158, okay? The two blue equations underneath example 8. Your first equation is y1 u1 prime plus y2 u1 prime is equal to 0. the second one is equal to f of x. In our case, the f of x is 1 over x. Sorry. So, your numerator determinant from Cramer's rule is you put 0, 1 over x here, e to the minus x, minus e to the minus x, right? And do that determinant. Okay? And Victor's here. By the way, I don't know if you realized it or not, but you weren't here till now.
Yeah, I asked her if
There it is.
I asked earlier if you weren't present. I don't think you heard me.
Okay. In fact, the other folks weren't absent before. Okay. Yesterday, Tuesday. I've got to get them absent. And actually, Ashley was present today. She came in earlier. Cameron's present and Victor's present. Top 3 are here. Good. Or were here. Bottom 2, though. Oh, actually, Rena came in yesterday. So I'm going to mark her as present today, too. Missing Javon. He was here one time in the recent history. Okay. So that's your Wronskian, it's the W1 Wronskian. And that would be what? Minus e to the minus x over x. Now, frankly, I would be almost prefer to write it as minus 1 over x e to the x. I don't know. Which way do they write it? They probably write it like this, don't they? Yeah. Which I find is a little strange, but well, they say e to the x times 1 over x, which is the same thing. Okay, our u2 prime, from what we did before, this time the Wronskian 2, the sequel, is e to the x, 0, 1 over x. Okay, and its is, yeah, e to the x over x. Over, oh, wait. The u1 is over the negative 2, and this is over negative 2. All right. So that u1 prime is then, the minuses go out, and what you have, du1 dx is equal to e to the minus x over x over 2x. Okay? So I'm going to say u1 is equal to the integral, 1/2 the integral of e to the minus x. And here again, I'm going to write it as x to the minus 1 dx. Okay. And how are you going to solve that equation? Kinda in integration, we call that. No, it's not separation of variables. That's what it probably looked like I was trying to charade, but that wasn't it. What integration technique do we use that is based on the product rule? You might almost call it integration by products, but they have a different name for it. Integration by parts. Okay. And parts is parts. Okay. So, what would you let be what? Yuck. Let u equal which one of those? That's my question. I thought I was quizzing you. Okay. But you turned it around and you're quizzing me. Okay. I got multiple choice here, don't I? Oh. Okay. If you do that when you do a du, it becomes minus e to the minus 2. X to the minus 2. Which actually gets worse.
Right. And the
Yeah. Yeah. E to the minus x. And then du, okay, that's what I'm suggesting, is equal to what? Huh?
I said, well, that's what I said.
Oh, I thought you said x to the minus 1. Oh, I'm sorry. Okay, what you get? Negative e to the minus x dx, and that would make then the dv equal, and believe it or not, I'm going to write it that way, 1 over x dx. That's what's the antiderivative of that? Log x, exactly. So then v is equal to log x, natural log of x. Yeah. Okay. So what does this come out being? 1/2. And you start with uv, right? So that would be e to the minus x log x, or log x e to the minus x. I don't know which one you want to put first. Both of them are pretty ugly that way. Minus the integral. And I don't know if you want to just keep the 1/2 with that. I think maybe so. And then what does this give us? Okay, so that's going to be a plus e to the minus x. No, it's the bottom line, ln of x, which, now that I think about it, isn't much better. Okay, and that would have a dx with it. Huh. Now, if you do it the same way again, with u being e to the minus x, no, can't do that. dv log x, I don't know what, when you take the derivative of it, you get log x. Nothing I can think of. Derivative of log x is 1 over x, but what would be derivative of what function would be log x? I don't know of one. Okay, so this isn't getting us very far. I was thinking it would. So guess what they do? They leave it in integral form. Old joy. Okay, which basically is going to mean you're going to wind up having to do probably numerical integration. Okay, and now, so much for this. All of our efforts here, they came to naught. Okay, so good try, but it doesn't get you anywhere you need to go. And the one thing not to do is to change your order and they make the log x your u and the e to the minus x your dv, because then you're just undoing it and getting right back where you started from before. So don't do that and think you're getting anywhere. You're going backwards then. But this has nothing you can do here. So it looked promising, but looks can be deceiving. Okay, so we just leave it like this, and they do go back and actually write this way. Because you need u to be a function of x. So they write this as 1/2 the integral from x0 to x. You know, sort of doing your fundamental theorem of calculus, part 2-ish or 1-ish, whichever part that is. E to the minus t over t, which is how we really started, dt. Now, the other thing you have to do is determine where that x0 could be. Frankly, x0 cannot be 0, because this would be a e to the 1. That would be okay. This one would not. 1 over 0, which you cannot do. So as long as the domain of t, or in this case, as your x0 is greater than 0, this is a legitimate answer. Okay, but you have to specify that. This is only good for x0 is greater than 1, greater than 0. Now you might argue this may be okay for x is less than 0 as well, just can't equal 0. That gets a little messy, but I think we'll go with the greater than. Okay. What they say in this example, we integrate on any interval 0, x is 0 to x that does not contain the origin. So that does include the positive side and the negative side. Okay. They say they'll do an alternate method in section 4.8. We're not going to get there. If you want to see it, go for it. Okay. Now, your U2, very similarly, you're going to be integrating that one, and that's going to be negative 1/2 the integral of e to the x over x dx. Okay, but written in this form, it's negative 1/2 the integral x0 to x e to the t over t dt as long. Second? Yeah, exactly. Same. So both of them work that way. Right. Right. Now, what they call these non-elementary integrals. Okay. So, running out of room, so I think I can delete a bunch of stuff. Right. Hopefully we won't need that anymore. Sure do hope not. Yeah. Okay. Okay. Do want to hang on to the first part. And I don't think we need this anymore. And we probably need some of that, so we'll hang on to it for the time being. All right. Your particular solution then, yp, we got the characteristic solution there. Particular solution would then be this first one, 1/2 the integral x0 to x e to the minus t over t dt. Okay. Minus 1/2 okay. All right. Got to figure out what they are doing with this one. They've thrown it, I'm sorry, I left off something myself. E to the x. Okay. Now, okay. Minus 1/2 e to the minus x times the integral from x0 to x e to the t over t dt. Okay. Now, remembering with a particular solution, what you do with that is, if you go back to page 159, flip one page back, the summary of the method, next to the last line, the particular solution is yp is equal to u1, that's your integral ones here, y1, that's your y1 from here. See, there's your y1, there's your y2, okay? So that's why your integral part is one part of it, and your u1s is one part of it, and your y1s are the other part. So that's why the e to the x and e to the minus x snuck in. They snuck in there and snuck in there. You don't need the constants, you just need the function, and then the 1/2 went with this. This is from here, and that's from there. Okay? So your total solution, y is equal to yc plus yp, and that is c1 e to the x plus c2 e to the minus x plus 1/2 e to the x integral from x0 to x e to the minus t over t dt minus 1/2 e to the minus x integral from x0 to x e to the t over t dt. And that, until 4.8, far as we can carry it. What's that?
I'm just making sure I got it. Oh, yeah, it's power.
Okay. Okay. So, all right, to erase? Got it? Okay. All right. Next, last little blurb they do here. The method you've just examined for non-homogeneous second-order difference equations can be generalized to the linear nth order equations, remember, linear nth order equations that have been put into standard form. And here's the standard form. Y to the nth. Now remember, they do single prime for first derivative, double prime for second derivative. You can do a triple prime for third derivative. But at some point, for the derivative, they put it in parentheses. So this is not raised to the nth power, it's in parentheses. This is the nth derivative of y. Now notice what you don't have here. You don't have a coefficient. Either a constant coefficient or a polynomial coefficient. You have divided that out. If your original problem had some function of x there as a coefficient, divide it out so you're left with just the nth derivative by itself. And then whatever else you have, they put p's. These are not necessarily polynomial functions. These are just functions. P to the n minus 1 No, I take that back. To do this technique, they do have to be, I think, polynomial functions. I think they cannot be rational functions. So therefore, whatever that coefficient was of the nth derivative, in order to be able to do this, you have to have these, I think they have to be polynomial. I've got to go back and think on that for a minute. P to the Pn minus 1, that just identifies which derivative goes with, of x, y to the n minus 1, okay, plus, and then they cut this early, dot, 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 and then pick up on the P1 of X, Y prime, plus P0 of X, Y equal to F of X. I'll make sure what they called it in this case. Sometimes it's G of X, sometimes it's F of X. Okay. Now, I kind of find it a little disingenuous that they're letting those coefficients be functions of X, whereas example 1, example 2, example 3, they've all been numerical coefficients, not polynomials, okay? So that's why I was really hesitating. This is really an extension of this, okay? And frankly, I don't think it works. I don't know why they're putting these should just be constants in my mind, because I don't think you can say the next statement if it's not. Your y of c is equal to c1 y1 plus c2 y2 plus dot, 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 up to c n y n. Okay. That's your characteristic equation. Okay. I mean complementary equation. And you set that, well, they don't say those are functions of x's either. Now, if you go back to the last section, they still were keeping everything with constants in front. I don't think we had any of them that we had functions. Now, this section it said linear second order on page 158. They did allow those, but then every example they've given us has not had them, which is, that's not docking here, is it? Okay. That's, so they are correct, you can do this, but they gave us no examples of it, okay? We did sort of a generic one without variables in there, but then every example they gave us had the constants, which I don't like the idea of, but it is true. So this is correct. You would get that form. Now your particular solution, yp for this would then be and you go through the same way we did before. Remember, the yp is your u1, and that's a function of x, times y1, which is a function of x. This y1 is the same as those, okay? Plus u2 of x, y2 of x. And the y's, again, are the same as those. They didn't put the x's in there above, but they are in there now. Plus dot, 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 plus u sub n of x, y sub n of x. And that y sub n, of course, is the same as that. There's your particular solution. All right. Now, how did you get the u's? Okay. You got the u's by doing your u prime like we did at the top of the next page, they carry it through. Now you no longer have a 2x2 matrix. That's real easy to take a determinant of. You now have an n by n matrix. Taking a determinant of those babies are a lot worse, okay? But doable, okay? Hopefully you program a computer to do them, okay? Or something of that order. But anyway, you get your each of these, you wind up with, and that equation is all in terms of u primes, and you get your u1 prime and so on. So u sub k prime for any one of them, which happens to be, then it'll be the determinant of your w sub k over the determinant of the w. The determinant of the w is just your, on the top row of this, it's going to be y1, y2, y3, y4, up to yn, and then the second row will be y prime, y2, double prime, y prime, y1 prime, y2 prime, y3, yeah, all like that. The third row, y1 triple prime, double prime, y, yeah, all the way down. To get your n rows, you go to the y to the n minus 1 derivative, n minus first derivative. Don't go to the n, just to the n minus first.
The bars around the w's for Wronski in there, that means
Determinant, exactly.
It's not it's make sure it wasn't absolute value.
Yeah, so that I just described the denominator. The numerator, then they didn't tell you how to go any further on this. Remember, in 2x2, it was a 0 and f of x, okay? That's what you put there. Now, notice what they do here. It's 0, 0, 0, 0, 0, and only the last one is f of x, okay? And I feel like they haven't done a particularly great job of saying why that's the case. But it is the case, okay? The constant thing is all zeros. So for the kth one here, every column except the kth column would be just like the Wronskian below, but the kth column would be 0, 0, 0, 0 down to f of x. I mean, yeah, f of x, okay? And then your and you do that for every one of them, okay? And they don't show you any examples, they just sort of talk you through that. They do show a 3x3 case. And
Should we do one?
what's that?
Should we do one?
Okay, let's see if we can find one.
It's 25 to 28.
Okay,
27.
yeah, so 27 is the one you want to do. Sounds good to me. So we'll clear this, and let's do 27. Page 162. This is what do they call this? Exercise 4.6. Number 27 is what you said, right? All right. Thank goodness they only listed constant coefficients. So here we have y triple prime minus 2 y double prime. No, yeah, minus y prime plus 2y is equal to e to the 4x.
So start out by finding the auxiliary equation.
Right, and what's it?
M
M cubed
minus 2m squared minus m plus 2.
equals 0. And what do you notice you can do here? Been a while since you used technique, I think, but it's there. By grouping. Okay. First, okay. First group, what can you do? An m squared, and that leaves you with a m minus 2. Second group, negative 1. What does that leave you with? M minus 2. And then you can factor out m minus 2, and that leaves you with a m squared minus 1, which will factor into, okay, m squared minus 1. Second, m minus 2 times what? M plus 1 times m minus 1. So we got our 3 m's. They make Scotch tape, by the way. M equal 2, minus 1, and 1. Okay? So that gives us our y sub c of,
I know what that is. They're putting in projector mounts.
oh, they're going to do this room soon too. Okay?
Okay. Sorry, lost my train of thought.
Get back on track. Okay.
Okay,
Say again.
this is C1.
C1,
Is it e to the 2x
2x,
plus
C2,
e to the
e to the which?
x?
X, that's fine.
Okay, and then plus C3 e to the minus.
Okay. Doesn't matter what you do, what order you do. It will later, but right now at this stage it doesn't. Okay. Now, next.
We gotta find our e primes and stuff.
Yeah,
Or Wronski.
the Wronskian.
Right.
So
It's gonna be a
we take these three, and since you chose them this way, that will be what? E to the 2x, e to the x, and e to the minus x. First derivative would be, oh, yeah, so 2e to the 2x, e to the x, minus e to the minus x. Next,
second derivative.
yeah,
Okay, 4e to the 2x, e to the x, and e to the 2x.
okay.
I'm glad that I picked one with e.
Yeah, well,
Or no, not with e. I'm glad it has e.
right, okay. Now, the Wronskian, the W, is going to be the determinant of that. Old joy is what we say. Okay? Okay. Now, to do the determinant of that, pick a row or pick a column.
Okay, let's see. I would say the middle column.
Middle column looks like a probably pretty good one to choose, and do a determinant from there. So the determinant of that, this position is a negative position. It's a minus e to the x times the determinant of what's left over. 2e to the 2x minus e to the minus x, 4e to the 2x, e to the minus x. Okay? And then you got to do a determinant of that. We'll come back and do that in a minute. Going down, you have a plus e to the x, and then you do the determinant of what's left over there. E to the 2x, e to the minus x, 4e to the 2x, e to the minus x. Then you'll do another minus e to the x times the determinant of what's left over there, which would be e to the 2x, e to the minus x, 2e to the 2x, x, minus e to the minus x. Okay. This is just going to get this W. We've still got to get,
The denominator.
yeah, the numerator. This is going to be the denominator. Okay. Right. Now, I hope it won't screw you up too much. I'm going to do them in a different order because I like to lead off with a positive. So this is going to be an e to the x, e to the 2x, e to the minus x. What I'm doing is that one there, right? I'm starting with that one because it's positive. Going to do this times those two, minus e to the x, e to the minus x, 4 e to the 2x. That's the minus this way, right? Okay. Now I'll go back to the top one and do a minus e to the x this way, e to the 2x, e to the minus x. Minus, which is going to be a plus, e to the x, 2e to the 2x. No. Nah, don't do that.
Control Z.
Say again?
I don't know if you can do Control Z at this point.
Yeah.
Well, we could start off from the matrices where we left off.
Okay.
So,
Okay.
we had a negative e to the x out in front of the first one.
Okay. Have you gotten what I had so far?
I didn't get all the way done.
Oh,
Okay. I got the matrices.
okay. So tell me what you got.
Minus e to the minus, or no, minus e to the x, sorry. Alright, and then the 2e to the 2x.
Is this a matrix?
Right.
2e to the 2x.
Next to that, negative e to the negative x.
4e to the 2x, e to the minus x.
Right. And then
Plus e to the x, e to the 2x, e to the minus x, 4e to the 2x, e to the minus x, minus e to the x, e to the 2x, e to the minus x. So I got, yeah, 2 e to the 2x, e to the, not, it's not a minus, is it? Yeah, it is. It is a minus x, e to the minus x. Okay. That's where we had started. And what I was going to do from here is, starting with this one, e to the x, e to the 2x, e to the minus x.
Oh, okay. Yeah, okay, that makes sense now. I didn't see what you were doing.
Minus e to the x, going this way, e to the minus x, 4e to the 2x. Okay, then I'll go to the first one, minus e to the x, 2e to the 2x, e to the minus x, then negative that, so that's going to be a plus e to the x, e, it's going to be a minus because that's going to be a minus. Yuck.
It says a minus again.
Okay. The minus, and then the minus, but then another minus. So that's a minus e to the x, e to the minus x, 4e to the x. 2x, I'm sorry. Okay, that took care of that one. Minus e to the x, this one. And then there's another minus there, that's going to be plus e to the 2x, e to the minus x. Just got one more. That's going to be plus e to the x, e to the minus x, 2e to the 2x. All right. Looks pretty nasty, doesn't it? Except that e to the x times e to the minus x is 1. Notice the sound effect? Okay. Those all go to 1. Okay? So this leaves us with e to the 2x minus e to the 4 e to the 2x minus 2e to the 2x minus 4e to the 2x plus e to the 2x plus 2e to the 2x. Doesn't it? We should have 3 pluses and 3 minuses. We do. So let's add them up. That's minus 8, minus 10. Oops, this one and this one go out. They've been dating. So that's minus 8 plus 2. So that is negative 6e to the 2x. Did you ever think it was going to come out that simple?
I mean, it's e to the x, though.
Yeah, you were hoping. Hope springs eternal. Okay. So that's the Wronskian. That's your denominator. Okay?
We got half of part of the problem.
We got a fourth of this part of the problem done because we've got to do a W1, W2, and a W3. So this is just 1/4 of that. But those will be a little bit easier because the first one is going to be the determinant of 0, 0, e to the 4x. Right? And then you'll have to fill in what were the second 2 columns of your first Wronskian. Oh yeah, I should have remembered that one. And this is e to the minus x, minus e to the minus x, and e to the minus x. Okay. Guess which one I want to choose? Yes, okay, the first column. First column. So this determinant is just going to be this times that. And that's a plus position, right? So this is W1, by the way. Okay? And W1 is going to be e to the 4x times the cross of that, which is 1, e to the x times that. And this is my word, though. No, I'm sorry. I couldn't read my thing. It's a minus 1. Minus 1, so that's minus 2. Minus 2e to the 4x. Right? That's our W1. Yeah. Our W2, I'm banking is going to be fairly close to that. And that's going to be e to the 2x, 2e to the 2x, 4e to the 2x, 0, 0, e to the 4x, e to the minus x, minus e to the minus x, e to the minus x. Did I do it right?
Yes.
Okay. And then let's use the
middle column.
And that's going to be, that's a negative position there. So it's going to be minus e to the 4x. Have you done determinants before? Do you know what we're doing here? I forget that he's been in linear algebra. I can't remember if you had. Okay, good. All right. Well, I'd say the sign of the position. Plus, minus, plus, minus, plus, minus, plus, minus. Any way you go. Plus, minus, plus, minus. That's a minus position. Plus, minus, plus, minus. Any way you get there. Plus, minus, plus, minus. Okay. Any way you want to, that's a minus position. You alternate. So it's minus e to the 4x times the product here, which is going to be another minus, which is a plus, e to the x. Because e to the 2x times e to the minus x is e to the x, right? Okay? And then 2e to the x. So this becomes 2e to the 6x. Okay? Wasn't quite as similar as I thought it would be, but it's not bad. Okay? And then W3. Can we squeeze it over here?
I had to turn the page.
Okay. This one will be e to the 2x, 2e to the 2x, 4e to the 2x, e to the x, e to the x, e to the x, and then 0, 0, e to the 4x. Okay, I'll choose that one, which is a positive position, times the determinant of this, and this is going to be e to the 4x e to the 3x minus, I'll put the minus out front. Now wait a minute, let me make sure. No, what am I doing here, folks? It's a minus, not a multiplied by a minus. When you do that determinant, it's this cross minus that cross, not multiplied by a minus. Oh my word. This whole thing's screwed up.
Well, not the.
Yes, the
line below where we did our.
yeah, that's right. Yeah, that one's okay.
Right, because you have the
Yeah.
first part minus the second part. I think just the last that we
Okay. The Ronskian we got right. That's W. That's okay. Now let's see where I screwed up on this one.
I think the W1 might even be right because it was like a negative 1 minus 1, which was a negative 2 or something like that.
Let me, to convince myself, I'm going to, I'll regret it if I've erased all this and then I don't have to, but I believe I did mess it up. Oh, but I think we were through with it anyway. I took out part of my Ronskian, but I think we're okay with that. Okay. Yeah. Okay. You let me get away with that. Okay. It's e to the 4x, and that's a positive position.
I got 0 for the first W. Then you have
And that's a minus 1, right? When you do that, that was a minus 1, right? E to the x times minus e to the minus x is minus 1, so that made it a minus this, and then e to the 4x minus that would be, is that what we had before?
well, you got to do.
No, it's,
Wouldn't it have to be? All right, so let's write it out for a second.
okay. This one here, e to the x,
E to the x,
e to the x, e to the minus x, minus e to the minus x,
e to the 4x out front.
and e to the 4x out front.
And e to the 4x
times that
times e
minus
to
1.
x. Is it? Okay, so minus 1. So
Yeah.
you get a negative e to the 4x minus.
Yeah, minus e to the 4x. So it's minus 2 e to the 4x.
Yeah.
Yeah, this determinant, just do the determinant. Minus 1 is minus 2.
Okay.
So it's
I got it.
minus
I
2.
got it.
Okay, is that what we had before? W1?
I think I erased it.
Okay. So anyway, it's minus 2 e to the minus 2 e to the 4x. Now let's do W2. That would be e to the 2x, 2e to the 2x, 4e to the 2x, 0, 0, e to the 4x, e to the minus x, minus e to the minus x, e to the minus x. So that's going to be e to the 4x times that. Negative e to the x minus 2 e to the x. So that'd be minus 3 e to the x. So that'd be minus 3 e to the 5x. I don't think that's what we got before. Okay. But we're in the right ballpark now. Now let's do our W3, which would be e to the 2x, 2e to the 2x, 4e to the 2x, e to the x, e to the x, e to the x, 0, 0, e to the 4x. Okay, and that's going to be e to the 4x. That's a positive. Oh, wait. That was a minus here. I forgot to do that. Minus position, so that's going to be a plus. Okay. This is a plus position, and then we do that. E to the 3x minus 2e to the 3x is minus e to the 3x, right? And that would be minus e to the 7x. Wow, I wasn't expecting that to go up that big, but I guess it is. This is so much fun, isn't it? It's your idea, wasn't it? Okay. Now.
I like matrices.
I can tell. Okay. Okay. I think I can safely erase the top, can I? Please say yes. Okay. I'll hit the right key this time.
You can erase probably the row as well where you mark through all the indexes. After that, I'm not too sure.
I'm not much sure of anything now.
It's so cold in here.
Okay.
Is it 63 degrees? It's 63 degrees in here.
This is outrageous.
It's getting colder.
Yeah, it's getting colder outside too. I think I can
Take the next, yeah, so you can take the, well, no,
everything but the Ronskians.
Okay.
I'll get rid of those two. Okay. Maybe I'll regret that, but I hope not. I hope I think I'm safe there. If we did it right, I'm safe. If we didn't, we're screwed anyway. Okay. All right. So our U1 prime is equal to W1, which was minus 2e to the 4x over minus 6e to the 2x. Right? W1 over W, which is 1/3 e to the 2x. Okay? Do we want to go on and do that? Let's leave it blank for now. Okay, let's write them underneath. Okay, U2 prime is equal to 3 e to the 5x, I sure hope we did that right, over minus 6 e to the 2x, which will be negative e to the 3x over 2. Right? And U3 prime is equal to minus e to the 7th x, okay, over negative 6 e to the 2x, which will be e to the 5x over 6. Okay. Now let's integrate. I messed up a little bit, but okay, we can deal with it. And this is 1/6 e to the 2x. Right? Okay. I've got some cheap land in Florida, I'll show you. Okay. Minus, I think this is going to be a 1/6 also, e to the 3x. It's a minus. Okay. And this will be, wow, a 1/30th e to the 5x. Strange but true, I guess. Okay. Now, our particular solution, yp is equal to your characteristic solution. Now, you have to tell me what order we did these in. It's important here.
Okay.
The y1 was e to the 2x. When you did y sub c.
You did y sub c. All right. So your first one was c1 e to the 2x.
Okay, e to the 2x.
Right.
So this is 1/6 e to the 4x. Okay.
Next one is just e to the x.
E to the x.
Right.
So that would be minus 1/6 e to the 4x.
All right. And the next one is e. Yeah, e to the minus x.
Plus 1 over 30 e to the 4x. So what does that do?
Oh my God.
1/30th e to the 4x. Can we be living that right? I don't know. This is really suspicious here. So your overall solution, y is equal to c1 e to the 2x plus c2 e to the x plus c3 e to the minus x plus 1/30th e to the 4x. Da-da-da-da-da-dum. Drum roll, please. Okay. This is 4.627. C1 e to the x. They put them in the wrong order. C2 e to the minus x. In the wrong order. C3 e to the 2x. Okay. Plus 1 over 30th e to the 4x. Cha-ching. We got it.
All that rewriting and erasing was worth it. And we're
The order you do the first three doesn't matter. but you've got to get
You gotta keep the last
the
answer.
Y ones with the U ones. You know, that was the important part of the order, and boy, did it work out okay.
What a way to end differential equations. Last class. So.
Yeah, that we got something right. Is that what you're trying to say?
Yeah. That's exactly.
Well, that and the fact my phone died.
Yeah, it's 10:47.
It's what?
10:47.
Okay, and we're supposed to end at 10:45, right? Okay. I haven't used the phone that much. I can't believe it's dead. I mean,
Have you charged it recently?
no, but it must just run down with practically no use.
How long has it been since you charged it?
Well, how long have I had the phone? Monday? Yeah. It will run down that quickly, huh? I thought with you
That's
using
holding a
it would.
charge a really long time.
What's that?
That's holding a charge a really long time.
Okay. Well, I thought with use it would wear it down.
Well, yeah, with use,
Huh?
that'll make it even shorter. If you use
Okay.
a lot, it'll last a day.
All right. So here, before you go, let me give you your last test.
We gonna burn that tomorrow?
Yeah, I will. Yeah. At least as far as I know, I will.
And is there one of these questions on there?
No, nothing that difficult.
Oh man. There's 5 questions.
Yeah, but they have multiple parts.
You don't say. Goodness. Let's see. All you gotta do is tell if it's independent or dependent.
Exactly. On the first A through H.
And I'm guessing, well, it's gonna be worth 10 points. So.
Well, I don't know what it's worth. Well, I'll figure that out later.
I mean, it's a fifth of the test.
Right.
At minimum.
And then the A through F, you just tell me whether the method of undetermined coefficients will be useful in that one or variations parameters. And they're both all yes or no's there.
Try it out and see if it works, and if it doesn't, try the other, and if it works.
Yeah. And by the way,
Let me ask
that
something.
one works doesn't mean the other won't work.
I was about to say, will at least one of the two
Yes.
work? Okay, so will both ever work?
Both of them could work on some of them.
So we write something each.
What's that?
You got to put yes or
And then the last three you do like we just did. So number 5 is similar to the one we did only with 2. Yes.
the one we just did.
Yeah, except that was third derivative. This is only second.
Well, see, I'm glad I asked you to do it.
Yes.
Now.
Okay. But
Because
the 3 and 4 is the first part of what we did. They're homogeneous. And it is a third derivative
Can
there.
we use this on those?
Huh?
I said, can we use this on those?
Oh, why didn't I think of that? Okay. Okay.
I like this because it makes sense. to
Yeah.
me.
Actually, once you get to doing the real stuff without all the fluffy stuff, differential equations is fun and cold. Okay. All right.
I'm gonna go out in the hallway. where
And
it's
you
warm.
still haven't given me your first test, right? Okay. So get both of them to me by Thursday because I won't be in town on Friday. I mean, I'll be leaving town on Friday, so I won't be on campus on Friday.
Where's the heat coming